All right, so we've dealt with the A, or sorry, we dealt with the B, we dealt with the C, and now we're going to deal with A, both what's in front of A and A itself. So again, as we've been talking, A is going to have a transformation, and something that goes in front will have a transformation. And we've already dealt with B, which goes left to right. We've dealt with C, which goes up or down. So vertical and horizontal. We've talked about those already. All right, so A, this is one of those things that it's not bad at all. It's not really hard at all. It's actually just one of the things you have to keep in mind. So just like the other rules, you have to just remember those rules. Same thing happens here. When it comes to A, I'm going to circle A. A either compresses or expands the function. And depending on what book you deal with, it might say vertically stretch or vertically press or vertically compresses. They might say stretch. They might say expand. Pretty much they do different things, but it means pretty much the same stuff. So here, if A is greater than 1, that means the function is going to compress together. So for example, if we have the absolute value function, and we say A is greater than 1, so A is like 15 or 5 or 2, that means it's going to compress. It's going to come in closer. It's going to shrink it up. It's going to squish it in. So as you see, it squished in more than it did with the original absolute value function. So if it's greater than 1, it's going to compress. If it's between 0 and 1, it's going to expand it. It's going to expand it out. It's going to make it larger, wider. So here, for example, let's say we had the parabola here, the quadratic function. If we're talking about it's going to be between 0 and 1, it's going to make it wider, bigger. So just like here, it made it bigger. So if it's between 0 and 1, it's going to expand. If it's greater than 1, it's going to condense it, shrink it, condense it in, bring it in, squeeze it. Bring the anaconda squeeze. If you don't know anything about the Nacho Libre, anaconda squeeze. All right, so the other thing is A can actually be a negative. Well, not A, sorry, take it back. There can also be a negative in front of A. Now, with A, it either is greater than 1 or between 0 and 1. It does not deal with anything that's less than 1, like as in a negative number. It doesn't deal with that. That's a totally different transformation. So here, this negative right here is a totally different transformation than the compressing and expanding. So negative means that it's going to flip across the x-axis or flip about the x-axis. That's a totally different transformation than the expanding and condensing. So with this, there's actually 4 transformations that can happen. It can go up or down, left or right. It can actually shrink or expand, compress or expand, and it can flip. The negative means flip. So there's 4 transformations that can happen. So here, again, we're talking about expanding and condensing or compressing, and then we have a flip. So if it's negative in front, it's a flip. So in other words, let's show it like this. If there's a negative in front, it's going to flip. So we're going to have to deal with a flip. So if it's, in other words, if it's facing up, it's going to face down. It's going to flip. That's all. So again, there's 4 different transformations. We're going to look at 2 of these right now with the negative and with the A. Okay. So here, let's go to example 4. And they give us, they say, okay, using the parent graph, f of x equals the absolute value of x, to sketch the graph of each function. And it says f of x equals the negative absolute value of x plus 3 plus 4. Okay, so with this part, we're going to look at the transformations that are happening. We're going to graph out the parent function. We're going to make the transformations. And then that's going to be the end of it. Okay. So first off, before we do any of this, you should be able to look at it and say, okay, oh, that's absolute value because that's an absolute value sign right there. So absolute value, we know that's the parent function. Absolute value. Okay. So with that, we know, okay, there's some transformations happening. So here we have a plus 4, we have a plus 3, and we have a negative right here, And then there's an understood one for A. So when A is equal to 1, when A equals 1, nothing expands or shrinks. Nothing, expands or condenses. All right, so here we're going to start off with an absolute value first, and then we're going to move in the actual parent function, and then we're going to move into the actual transformations. So I'm going to do the parent function in black. Again, dotted line because it's going to be the parent. The solid line is going to be for the actual transform graph. All right, so we're going to go up 4. We're going to go to the left 3. Then we're going to flip here. So again, remember, it goes up for positive for the back. It's going to go to the left, because it'll go opposite of what you think for the inside. And then the negative in front makes it flip. All right. So with that, let's go ahead and do our transformations now. So here, we're going to move this point that's at the origin. Always move it from the origin. Move over 1, 2, 3. So start here and go over 1, 2, 3. We go up 4. So from here we go up 1. Go up. Up. 1, 2, 3, 4. And we put a dot there because there's no more transformations in movement. And again, this goes over 3. This goes up 4. And then the last part says that we are going to flip it. Because A does not equals 1, we don't have to expand or condense it. So we're going to flip it, means it's going down. So it's going down this way. And you know what, guys? That's it. That's all the transformations that happen. So the only thing is maybe we shrink it a little bit, like on another problem. But that's it. That's all that is with transformations. There's nothing brand new right here. That is all. So with that, enjoy it. Know that it's not that bad. And then that's cool. We're done.